Let's talk about how we take an EaganMatrix preset using the new firmware and modify it so that we can expose the interface for overlay control. Now, we won't talk about how to program presets in this video. It's already assumed that you know how to use the EaganMatrix for sound design. We'll talk about the extra features that you need to know about to program an overlay to interface with your preset for the control you need to create your external synth in most cases. I've created another preset, a simpler one than the mixture Trautonium preset. This also uses two EaganMatrix modules. Module 1 feeds into Module 2. This is an additive preset that lets you specify harmonics for up to 10 oscillators that are mixed together. The first 5 are set on Module 1. The second 5 on Module 2. The programming of each module is virtually identical. The second module adds a little bit of recirculation programming and convolution programming, and there's blend of persistence on all the oscillators. Each of the oscillators can be set with a harmonic number from 1 to 20. Each of the oscillators can be detuned, and you can change the timbre of each of the oscillators in parallel. That's going to be Y controlled. The preset to do this, you can see, is pretty simple. We'll talk about the new features in a bit. Let's just quickly go through what this preset does. We can go in and select a harmonic number. Let's say we want to set harmonics 1, 3, 5, 7, and 9. And we can set an amplitude on those. Let's bring down the reverb perhaps. We're using the new long reverb. So those are the first 5 harmonics on the first module that I can adjust in this overlay that uses the Electro 1. And so now let's bring in the other 5 oscillators. Maybe we'll make them harmonic numbers 1, 2, 4, 8, and 16, all. So we'll bring up oscillator 6. Let's detune that one a bit. You can hear the beating starting. So I can detune each oscillator. Let's bring up the levels on the others. So there's the basic function. Everything's done on this one menu. I can go in and add a little bit of release maybe. There you can hear that. We've already seen I can change the reverb. I can bring up the sine to saw function, and on Y you can hear that the timbre will change as I changed Y on the continue mini here. And finally, I can bring up the convolution. And you can hear that. So that's the basic preset. Now let's see how we take this simple preset and expose it so that I could create this overlay. So now let's look at the preset. Here you can see we have the 5 oscillators. Each one uses standard X on the frequency. There is a multiplier that is set that will provide my harmonic number. Here we have the formulas that will provide the detuning. Here's the formula that in parallel, formula P, changes the spectral bounce, the timbre of the oscillators. Here we have the convolution programming on the index and the mix. Here is just mix programming on recirculation. Here's our input from the audio of the first module into the second that we don't really need to worry about. And here are all my levels for the harmonics. So let's see how we have exposed these to the external interface. Now first let's talk about the new additions to the editor that will support this. We have 3 different types of macros that can be programmed for external use now. We have the standard 7-bit unipolar macros that we've always had that can be programmed on their normal CCs that you can find in the manual. These are the same CCs that these have used for a long, long time. But if we're going to program overlays, we probably are not going to use the 7-bit unipolar ones anymore, even though you can use those 1 to 6 macros that we've always used in the past. The majority of the interface will use and expose the new 14-bit, either bipolar or unipolar macros. These work as follows. CC86 is the least significant byte of the 7-bit component of the 14-bit macro, and then a CC from 40 to 119 will be used as the most significant 7 bits of that macro. And in the editor, there's a macro number that's defined from 7 to 48 that are CC86 centric, and then there's CC97 that is used as the least significant byte along with the CC, again 42 119 for the remaining 14-bit bipolar macros. Then there are the standard 6 macros that if you use CC86 before them, they turn into 14-bit unipolar macros. The range of these from the 14-bit perspective will be 0 to 16383 in both cases, bipolar and unipolar. The bipolar ones will have a negative component on the first half of the range. So for the bipolar macros, from 0 to 8191 will be negative, 8192 is 0, and 8193 to 16383 will be positive for the 14-bit bipolar macros. For the unipolar ones, they range 0 to 16383. So for these unipolar macros, in the positive direction, you get twice the resolution, but there's only 6 of them. So for the most part, you can see you'll be using the 14-bit bipolar macros. There's a total of 90 of these now that are exposed, adding up all of the bipolar and the unipolar macros, as opposed to just 6 that we've had thus far. We'll go into more detail on this in the next video, but the editor has a way to change each of these new macros with a control so that you can test things. Typically, you won't use the editor at all with the overlays. You'll use your overlay application, but at least the 90 controls are available in the editor for testing your interface. Now, you're always going to want to create a table of what each of your macros is doing, because there's so many of them, you're going to easily lose track of what functions in your preset do what based on what macros you have exposed. So I always keep a little table of what the macros are going to be. The new editor allows 22 additional formulas to be defined. So we have the original formulas A to V, and then there's A prime to V prime that add an additional 22 formulas. Those formulas can be copied between each other just like the current ones. Those formulas can be used in ancillaries. Anything you can do currently with a formula, you can do that with the new formulas as well. This expands things and opens up your ability to program more functions. And now let's talk about how we use these new macros. We can define a macro just like we used to in W, only now instead of 1 to 6, we can define any of the new macro numbers from M1 to M90. One of the things to be aware of is that when you're dealing with these new macros, when they're bipolar, on W, when you want a value of 1, you'll send 16383. When you want a number of 0, you need to send this value, as we said, 8192. And if you send a value of 0, you're going to get a negative 1. Your W is going to range now, not just from 0 to 1. It will range from -1 to 1 if you apply a bipolar macro to it. These macros now can also be set on X, Y, and Z. In that case, they will redefine the range of your X, Y, and Z that you can set in your overlay. So that, for example, if I wanted Z to only go to 50% and I assign a bipolar macro to M9, I can, in my overlay, I can set a value for M9 that will cap the Z value to 0.5, for example. Same thing I can do with the Y and the Z. These macros can be assigned to blend, as well as the new formulas can be assigned to blend. Ancillary operations can be assigned to a formula, and now they can be assigned to any of these new macros as well. In the formula display list, you'll see what macros are assigned to each one of the formulas, just like before, only now there's going to be a lot more macro numbers to deal with. And again, in the cogwheel section, you can bring up the controls to manually change the value of any of your new macros. Let's go back to our preset. Here on the levels, you can see I have, for the 5 oscillators that are controlled by this preset, I use macros 1, 2, 3, 4, and 5. So I'm using the 14-bit unipolar macro to get the full resolution on my amplitude level of the output, assuming, of course, I program in the overlay the 14-bit macro that has the least significant 7 bits set as CC86 and the most significant bits set as CC12, which would be the normal CC for macro 1. I also have set a blend here, you can see, of persistence that is controlled by macro 65. So there's really nothing new in how you're going to program these presets. The main difference is that you're going to expose the new macros. And of course, then we're going to have to talk about how you program those macros, because you no longer send 1 CC anymore. For these 14-bit macros, you're going to have to send a CC pair, a CC86 or a CC97, followed by the CC macro number that is going to pair with that for your 14-bit macro. Okay, in terms of my spectral balance, I use one formula here, and you can see it's all controlled by Y that's set to M64. The maximum value of Y is going to be set to 0.7. Your scalings are still going to be applied as you set them in your preset. So my max value out of this Y will still be 0.7, but now the max that can be set to will be set with the macro. So we have to be careful here, because I need to set my macro so that it's sending a positive value of 8193 or more, or I could set 8192 if I want that to set Y to 0. So if I set M64 to 8192, Y will have no effect. The maximum value Y can achieve up to the value 16383 as the 14-bit entity. The frequency harmonic multiplier, that uses macros 54, 55, 56, etc. And in my overlay, I'm going to program them so that they will send a 14-bit value scaled so that I can set 20 different values. Remember, in the matrix, you need to set a little bit more than you need to get your max value. These will be the 14-bit bipolar values. So if I send 8192 to this, it will set it to 0, which will be a 0 multiplier on frequency. I'll get no sound. I have to scale this now by dividing 8192, which is the maximum number of values I can have from 0 to max value in 14-bit bipolar computation. So if I set 16383, I'm going to get the last harmonic. And if I divide 8192 by 20, each one of those increments I will add to get one of my 20 harmonics. All this we'll spend a lot more time on when we do the programming. The detuning offsets, those detune to a max of 0.25 offset. Those are controlled by macros 59, 60, 61, etc. So I will send a value from 0 to 1 on those. These are 14-bit bipolar, so I'll send a value of 8192 to 16383 to get my full detuning range here. If I send a value less than 8192, this is going to set this to a negative number. I really don't want that in this case. Just remember, your 14-bit bipolar numbers are going to set negative values if you set a value less than 8192. And then I have M68 for the recirculator control, M67 and 66 for the convolution index and mix settings. These I have set as 14-bit bipolar macros again, so I'm going to want to set them to a value 0 to 1. Once again, I'll send a value of 8192 to 16383 to set these from my expected 0 to 1. If I send less than 8192, I'm actually going to be setting these to a negative number. Now, some things negative numbers affect the same way as positive things. A lot of other things, they will produce unexpected results. So just remember, whether you're using a 14-bit bipolar or unipolar macro, and you have to program them differently. Now, the last thing we'll say is you can do a lot of stuff with the overlay interface in addition to just applying 14-bit macros. Everything you can do in the editor is actually exposed in our new overlay interface through what's called pokes. We'll talk about those in the next video, but to give you just a hint, what you can do in your editor is go to Utilities, set yourself to MIDI log filter, bring up your console, clear that out, and if you send something or do something on this interface, you can see the data will be sent out accordingly. So let's go in and change, for example, change this oscillator from its DSF type to its integrated type. If I do that and I go in, I'll see the commands that had to be sent to do that. This matrix poke that sends a 20 for CC56, which means it's a matrix poke, and then it uses a poly aftertouch command to send two values that this is going to map to. We'll talk about that later, but basically those are the two main things that you need to program: the 14-bit macros and these matrix and formula and other pokes that will use CC56 as the indicator of what poke you're using, and then poly aftertouch messages to send your actual data you need to change the values for that poke. There's some other stuff that we'll look at, but those are the two main things that you need to think about when creating the overlays. And once again, overlays program presets exactly the way they are now in terms of sound design. The only thing you'll need to do is figure out what formulas you want to use, exposing what macros on them, so your overlay can take control and create the overlay interface you desire.